Welcome to the Crazy Hat Chemist. Today we are doing the third video of basic stoichiometric problems without balancing. So overall, this is the stoichiometry and dimensional analysis unit. There are 23 videos, but we're doing 4.3 here today, so let's go for it. Here we go. Bam! Okay, how many molecules are present in 1.590 grams of mercurous chloride? First of all, I want you to look at that number, 1.590. How many significant figures do you see? That's 4, because that trailing zero counts because of a decimal. We also need to get the formula for mercurous chloride. Mercurous is Hg, and it's a what charge? 2+, and there are 2 of them. It's almost like it's a diatomic. Chloride is a halide ion, and it has a 1- charge. So here's mercurous chloride. I'm going to take that 2+ charge, that 1- charge, absolute value of those 2 numbers, flip the numbers, bring it down, and I'm going to have Hg2Cl2, and that's my formula for mercurous chloride. Okay, I'm going to think about this flow chart. Where am I starting off at? I'm starting off with a mass. That's correct. That's awesome. And where am I going to end up with? Molecules. So the question is there a direct route? This is the direct route. From mass to molecules, is there a direct route? And the answer is no. There is absolutely not a direct route. So we're going to get rid of that. So what we have to do is we have to go from mass to moles. And then from moles, then we're going to go to molecules. Okay? So you're going to get the molar mass for mercurous chloride. You're going to solve that using your periodic table. Then you're going to go from the mass, that's 1.590 grams of mercurous chloride, and then you're going to go to moles. And then from moles, then you're going to go to molecules. You're going to have this as one giant long monorail. You could have intermediate steps, but I wouldn't do that. That's just more time and time-consuming and chance for error. So you're going to do one giant monorail here, and here's what we're going to come up with. Bam! Right here. So you should see that the grams cancels out of the mercurous chloride. Hopefully you got the right molar mass for mercurous chloride. It has 2 decimal places because mercury has 2 decimal places. Chloride has 3 decimal places. Okay, and then that will get you to moles. And notice that the moles are in the numerator there, and then you're going to cancel out the moles in the denominator. The next term, that's like that right there. And now 1 mole is equal to Avogadro's number. Hopefully you remember that from before talking about Avogadro's number. And that is the number of molecules in 1 mole. Okay, we're going to look at significant figures on this problem, and I have 4 significant figures on that first number that I talked about before. How many significant figures in 1 mole? That's infinite. How many significant figures in Avogadro's number? That's 4, that what I have. Now, some people might say that you could have more. You could write down as many significant figures as your teacher, instructor will allow you to do. But we're going to truncate it there at 4 for all our problems to keep it simple. How many significant figures in that molar mass? It's to 2 decimal places, but there are 5 significant figures. How many significant figures in the 1 in moles of mercurous chloride in the denominator in the molecules there? And that is infinite as well. So the fewest number of significant figures that we have on this problem is 4. So I'm going to get a number in my calculator, and then I'm going to round this with this 2, and then I will have 4 significant figures rounded correctly. And there's that number is 2.028 times 10 to the 21 molecules of Hg2Cl2. And on every single one of these problems, I am thinking about the inverse of fun, or the opposite of fun, and that's nuff. Okay, and that is number units formula. On all these stoichiometric problems, I'm writing a number, that's 1.590 units, grams, and then formula, Hg2Cl2. I have that as my beginning number, and I have number units formula for every single step. And that way I can cancel out my units, I can cancel out my formula, and then I will have the right answer. Okay? I saw this at a college kiosk at a local college town somewhere, and it had this on there: tutoring in chemistry. Call 6.022 times 10 to the 23rd. Look, one has already been taken off. You might want to get the next one. I am the Crazy Hat Chemist. I hope to see you next time. And the next time we're going to be talking about 4.4, another basic stoichiometric problem here. Study that flowchart and make sure you know it. Have a fantastic day. See you then. Bye.